Titan, the biggest moon of Saturn. Titan, the largest moon of the gas giant Saturn, has long been considered one of the most promising candidates for extraterrestrial life within our solar system. Measuring roughly twice the size of Earth's moon, Titan has captivated scientists for decades. Initial measurements of Titan's atmosphere, conducted using the Hubble Space Telescope and other instruments, revealed traces of gases suggesting the presence of organic compounds. While there was initial disappointment when the Cassini-Huygens mission confirmed that many of Titan's lakes likely consist of liquid methane rather than water, researchers later found compelling evidence suggesting the possibility of methane-based life forms. This discovery has ignited ongoing excitement about Titan's potential to harbor life. In this video, we explore the thrilling journey of discovery on Titan, uncovering what NASA has found and how these findings may reshape our understanding of life beyond Earth. Saturn's moon Titan, a captivating world. From afar, Titan resembles a greenish-brown version of our home planet. In fact, Titan and Earth are the only known celestial bodies within the solar system that possess stable atmospheres rich in clouds. Recent advancements in telescope technology have allowed scientists to observe Titan in greater detail, revealing structures that suggest the presence of seas and lakes. This greenish appearance, combined with its atmosphere, has positioned Titan as the leading candidate for discovering extraterrestrial life. The Cassini-Huygens mission. In October 1997, NASA launched the Cassini-Huygens spacecraft towards Saturn and Titan. While the Cassini orbiter studied Saturn for nearly 30 years, the Huygens lander had a singular mission: to fly through Titan's atmosphere and land on its surface. On December 25, 2005, Huygens separated from Cassini. 2 weeks later, it descended through Titan's atmosphere, collecting data for 2 hours and 28 minutes before landing. The lander then transmitted data from Titan's surface for an additional 56 minutes. This brief but crucial window of data collection dramatically expanded our understanding of Titan. Titan's atmosphere. Titan's nitrogen-rich atmosphere, much like Earth's, contains significant amounts of methane, hydrocarbons, and traces of organic compounds. Its nitrogen content is 98.4%, with no detectable oxygen. In the upper atmosphere, methane dominates, along with organic compounds like ethane, propane, ethene, and hydrogen cyanide. Huygens also detected traces of helium, carbon dioxide, and water. While nitrogen plays a critical role in life on Earth, the absence of oxygen highlights the stark differences between Earth's atmosphere and Titan's. What did Huygens find on Titan's surface? Huygens became the first probe to land on a moon other than Earth's moon. Before the mission, Titan was not a primary focus for NASA or other space agencies. However, its Earth-like characteristics sparked global interest. Upon landing, Huygens revealed a reddish and rocky landscape, complete with cliffs and shoreline-like features. Data from the mission confirmed the presence of a subsurface ocean. Titan's surface is coated with organic material, giving it a dark brownish-red appearance. The ground, resembling wet sand or mud, consists of a mix of frozen water and hydrocarbons. The probe also detected minor deposits of methane trapped in the soil. Either the heat from the probe released the methane or this was part of Titan's natural methane cycles, akin to Earth's water cycle. Methane lakes and life on Titan. Analysis of Huygens and Cassini data suggests that Titan's lakes are primarily filled with liquid methane rather than water. Methane, a colorless gas found on Earth as natural gas and biogas, plays a crucial role in Titan's environment. While initial findings of methane lakes were met with disappointment, some scientists proposed that methane-based life forms might exist on Titan. Could there be organisms that rely on methane instead of water and breathe pure nitrogen instead of oxygen? With our limited understanding of the universe's vast and diverse phenomena, the possibility of such life cannot be ruled out. Titan continues to be a fascinating world, offering a glimpse into the potential for life in conditions vastly different from those on Earth. Titan is the biggest moon of the gas monster Saturn. From now onward, indefinitely, this moon, which is about 2 times the size of our world's moon, has been viewed as the most promising contender for extraterrestrial life within the planetary system. Estimations of Titan's atmosphere were made with the Hubble Space Telescope, among other instruments. These revealed hints of gases that pointed to organic compounds. At first, there was great disappointment when it became known, after the Cassini-Huygens mission, that many of the lakes on Titan likely consist not of water but of liquid methane. However, the tumultuous roller coaster of whether or not there can be life on Titan led researchers to persuasive evidence suggesting the existence of methane-based life forms on Titan. Find out how this exciting cosmological thrill ride ultimately ended up and what type of life NASA found on Titan in this video. Before we go any further and introduce you to Saturn's moon, we'd like to invite you to subscribe to our channel and never miss another video about exciting space missions and the latest discoveries in far-off universes. If you enjoyed the video, we would, of course, greatly appreciate a thumbs up. Music. Saturn's moon Titan. Saturn's moon Titan is an intriguing world that, when seen from a distance, resembles a greenish-brown version of our home planet. In fact, Titan and Earth are the only celestial bodies found so far within the solar system that have stable atmospheres rich in clouds. Thanks to the latest telescopes, researchers have been able to observe Titan in greater detail over recent years. Among other things, they have discovered structures suggesting the presence of seas and lakes. Coupled with its greenish appearance and the fact that this world has an atmosphere, these observations have ensured that Titan became the top contender for the discovery of extraterrestrial life. The Cassini-Huygens mission. In October 1997, the twin Cassini-Huygens spacecraft launched from NASA's Florida spaceport towards Saturn and Titan. While Cassini orbited and studied Saturn for almost 30 years, the Huygens lander's mission was much shorter. Initially, Huygens had only one objective: to fly through Titan's atmosphere and land on its surface. On December 25, 2005, the time came. Huygens separated from Cassini. 2 weeks later, the lander descended into Titan's atmosphere, dangling from a parachute. Huygens collected data in the atmosphere for 2 hours and 28 minutes, after which the lander touched down on Titan's surface and gathered data for an additional 56 minutes. Those crucial hours helped us on Earth learn significantly more about Titan, though the mission fell far short of answering all the questions surrounding this fascinating moon. Titan's atmosphere. Titan's atmosphere is nitrogen-rich, much like our own on Earth, but with significant differences. It contains large amounts of methane, hydrocarbons, and traces of organic compounds. Titan's nitrogen content is 98.4%, and oxygen is entirely absent from its atmosphere. Methane dominates the upper layers of the atmosphere due to its low density. Remarkably, many organic compounds, such as ethane, propane, ethene, and hydrogen cyanide, have been found. Additionally, Huygens detected traces of helium, carbon dioxide, and water. Although nitrogen plays a critical role in Earth's biological processes that make life possible, Titan's atmosphere fundamentally differs from ours due to the absence of oxygen. What did Huygens find on Titan's surface? Huygens was the first probe to land on a moon other than Earth's moon. Initially, the moons of gas giants like Saturn and Jupiter did not garner significant interest from NASA or other space agencies. Only when it became evident that Titan resembled Earth in such a peculiar way did global interest increase. Since then, probes and telescopes have discovered many other moons around gas giants with unique surface conditions, volcanism, and traces of water. Unlike the gas giants themselves, which are primarily composed of gases, their moons are rocky worlds, much like our Earth. When Huygens landed on Titan, it revealed a reddish, rugged landscape with rocks and cliffs, along with evidence of shorelines. Data from Hubble and Cassini confirmed the presence of a sea. Titan's surface has a dark brownish-red color due to organic material deposits. The ground where the probe landed consists of contaminated water and hydrocarbons, similar in consistency to wet sand or clay. Huygens detected minor methane deposits in the soil shortly after landing. Either the probe's heat and weight thawed the soil, releasing methane, or the rising methane is part of Titan's natural gas and liquid cycles. Much like water vapor rises from Earth's ground and waterways to form clouds and eventually precipitates as rain, methane cycles might exist on Titan. Later analysis of the data from Huygens and Cassini provided increasing evidence that Titan's lakes are filled with liquid methane rather than liquid water. Methane is a colorless gas that occurs on Earth as natural gas and biogas, among other things, and is used as an energy source. In nature, swamps and forests produce large amounts of methane, and human activities such as rice farming, landfills, and cattle digestion contribute to its production. Along with carbon dioxide, nitrous oxide, and CFCs, methane is a long-lasting greenhouse gas, significantly influencing Earth's anthropogenic greenhouse effect. Does this rule out life on Titan? Initially, there was great disappointment among scientists who had envisioned the possibility of methane-based life. However, other voices quickly emerged, arguing that such life might still be possible. With our limited understanding of the universe and its vast peculiarities, how can we be certain that there aren't organisms somewhere that function with methane instead of water and breathe pure nitrogen instead of oxygen? Opponents of this theory suggest that life on Titan could, at the very least, consist of primitive forms, such as microbes or algae.